this.
Okay, sorry. I'll have to first integer.
We provided out with the matrix, two-dimensional matrix, and in that you do need to return where is the value which has been asked for.
Hmm.
And in this specific case, you can expect that there is only unique values which are present. So unique as in completely unique. Say completely unique values. Say that if 3 is there, 3 will be present only one in the complete array. Another thing to notice that your rows which will be present will be non-decreasing.
Okay. Can you give me an example of this?
There you go.
Okay.
Values are non-decreasing.
Hmm. Okay.
So, and in
Okay.
this one, you
Understood.
just need to tell whether the element is present or not.
Okay. See, there's an easy solution to it. Flatten the entire matrix and then do it.
Um,
But that will be
what do you mean
m
by
time.
flat and or like? Can you please elaborate that little?
So you just take each row and just append like 1, 3, 5, 7, 10, 11, 16, 20, like
Mm-hmm.
that.
And in that, you will be like when you're searching, you need to search it linearly, right? Not be a sorted array then.
No, why would it not be a sorted array? It's saying that the first integer of each row is greater than the last integer in the previous row.
Oh, okay. Yeah. Uh, that case, yes. I mean, I don't want you to get the next question.
So that would be an expression.
No, no. Please carry on. You were saying something.
Okay. Okay. Somehow, like now I have time for not just solving one, but there is also another question which I have a hint. So that's good. Uh, so flattening the matrix is one solution where flattening would take O of n plus after that it is going to be O of log m times n, but that comes out to be uh, n.
Mm-hmm.
So that would not be a good solution, but
Yeah.
that would work. That would work, right?
But in this one, like we are looking for a little bit better solution, with better complexity.
Okay. So one hint that I can get from this is that the last element, sorry, the first element of any row is bigger than the last element, and for each row it is going to be sorted. So basically, uh, I can actually do a binary search on the row first.
Yeah.
Sorry, not in the binary search on the column first, and I'll find out the number which is less than uh, the current value, less than or equal to the current the value that I want to find, and in that I will search the row. First, I'll search the column like this. I'll search 1, 10, and 23. Out of this, the target is 3. So in my binary search, it will yield as 1. 1 is the nearest number to that. So
Mm-hmm.
if it's not 1, then I'll search the row of wherever the 1 was.
Okay.
So do you think that would be a
Yeah.
good solution?
This is this is same as like binary search, but you're doing it in a app, right?
Yeah.
Cool. Go on. Yeah. Wow.
Mm, no, I'm just using the uh, previous question. Sorry, previous answer. Uh, should I actually change this?
Change what?
Should I actually start from the scratch?
No, no, no. You can take the reference from your.
Okay.
Now, in the times when interviewer says that you can take reference or you can use the template from your last code, they are usually seeking that um, how much less of a change that you can make in your last code and then again. So the idea is by the time you're giving out your first code, it will not always be possible that you can reuse it, but try to write it in such a manner that it can be easy. Right, Gotham?
Yeah. So I think this happened with me in one company's interview where I really wrote a code which was very difficult to like it. The question was difficult. I answered it, and then he put some question on top of that, and I could not solve it on time. This was like 2 years ago. That time I realized like system design and designing entire
Yes.
code is very important.
Yes.
So I have this function called solution. This is where I'm going to write the solution. So yeah. So for every row in matrix, I'm just going to put the row of 0. Okay.
Yeah.
So what I will do is, mm, okay, I'll have to run through this because I have made this change over here at line 39. Okay, so I'll have to run through this entire code and just see if this one is supposed to be start or the end.
Sure.
But yeah, so row numbers. So we'll do a binary search. This will give me an index.
Another one of the key point in an interview they do look for is how's your communication skill. If you are able to tell your ideas to the interview, that lies as one of the major hire or no hire.
Yep. So in this, I actually find out. See, I'll just use this as the comment. So let me just. So this one will become the 1, 10, and 23. So this should yield 1. But
Okay.
let's see. Let's when we run
Yeah, maybe
the
we can do
entire
a
process.
dry run and then.
Yeah. So I'll just tell you the logic basically. Now, after the index row is found, index column should be binary search of the matrix of row. And this should come as, oh, sorry, this one should be 0. return. So matrix of index row, comma, index index column. So this should work, but the thing is there is this thing that can happen,
Yeah.
and it's a true or false question. So that's a catch. If the value is not there, then you have to return as false, right?
Yes. Your line 49 is, I think, throwing an error. So you can look into that as well, right?
Yeah, yeah. Sorry, I got a very small screen, man. Sometimes it takes a little while to debug. Huh. So this should work, but there's a catch. So what if you put a number like 8? Let's check for 8.
Sure.
8, it will land on the first row, but then 8 is on the after 7, right?
Mm-hmm.
So basically, when you put 8, you will go out of bound. And if I actually check for matrix of index row, that will work. But the index column is going to go beyond the matrix.
Yes.
What if the value was anything beside that is okay? Like if the value was negative something,
Mm-hmm.
then what do you call this? This is still go and check on the zeroth index. So that is okay. Negative values are okay
So,
in this.
but in this case, for example, let's say that if my input is actually 8, that is a valid
Yeah,
input that we are expecting, like one of the valid test cases. So you say that your code would not stand in that?
yeah. I think I have to put a case,
Mm-hmm.
case where index column, if it is greater than or equal to length of, we'll just row count equal to length of matrix, column count equal to length of, so, so if it is greater than or equal to the column count, then uh, return false. Okay. Oh, Tushar has put, I think this is log m plus log n. Yeah, log n plus log n is basically log of m times n.
Yes, but like m plus, so I think he's with line number 52, he's saying
Hmm.
uh, m plus then log m cross n.
Yeah, yeah, I understand. So we can actually modify this binary search. Like there are two binary search we can use. Uh, One which just looks at the zeroth column and then do it. If you want, I can do that right now.
No,
So
there is one thing. Yeah, I see that you can optimize this one. The one thing that I did really like about your approach was that so quickly, like, tell me what's the other way that you think that you can solve with this? You were saying.
no, no, I'm just optimizing this. Like to be correct, you can just have binary search row and binary search column.
Mm-hmm.
Those will be two separate things. Binary search row will just search within the row,
Yeah.
and the column is going to be searching on like it will be the normal search, the simple one
Got
in
it.
the array.
Okay. Yeah, no, to be honest, like with you, the way that I was thinking was that we do need to take side by side the searches, like the usual pattern in which we have learned to find out the answer in 2D binary search. But I really like the way that you have completely leveraged your previous solution in line 51 and 52 to find out the answer. But yeah, as you're saying, please, if you think this is necessary for the optimization, uh, please go on, do it.
Uh, so basically, the thing was that if I actually write a copy of this function, I can avoid this.
Mm-hmm.
So it depends.
Got it. Yeah.
Like for now, I'm doing this because uh, in normal code, we can write a binary search for the row as separate entity. It's a uh,
Yeah. Got it. Okay.
oh, I think Tushar has a very good approach where you basically just find the entire length and then you basically do a binary search in that. That can also be done. So basically, what Tushar is suggesting is you basically take the entire length of the matrix, which is row count times column count, and you start and end with 0 comma length of matrix.
Yeah, this one goes to the native dimensional binary search approach.
Yeah, you can do that.
Yes, yes, Tushar, like that is the point. In this one, there is the regular method in which question is solved. But another way that this code is really appreciable is that Gautam is able to directly refine out that code just directly using the binary search two times, and then it's doing its work.
Yeah. So in that approach, I can just the value mid this part of the this part, I can just change that. We'll take the what do you call it? Start and end, and then you can just put like uh, mid modulus the length of no mid by row count and mid modulus row count. If I'm not wrong. Yeah. And by doing this, yeah, it's pretty straightforward. You can just use the binary search that is already given. Yeah. Kudos, Tushar. That's that's actually a better approach than this.